we're back to section 4.7, example 5. An oil refinery is located on the north bank of a straight river that is 2 kilometers wide. So this is the straight river, 2 kilometers wide. And it's the refinery is up here, and then there is a pipeline to be constructed to from the refinery to storage tank located in the south bank and 6 kilometers east. So here is 6 kilometers, and this is the storage tank. And so the question is asking to find to minimize the cost. Obviously we want the cost to be smallest. How do we find a point P on the north bank that you can connect R to that P and then S to that P as well? And the cost over land obviously much cheaper than the cost on the river. So the cost of laying pipe is $400,000 per kilometer over land and $800,000 per kilometer under the river to the tanks. And so think about this way. If I connect directly here, it will be all under the water and I have to pay the bigger price per kilometer. If I connect right the smallest direction in here, then I will go a long way on the bank before getting to the short way under the water. So how do we optimize this? And so and it turns out there is a point P in the middle that you can connect here and then you connect here, and this length you can call it L, and then times 800,000 plus this other length, you can call it T times 400,000 is going to add up to the smallest amount possible. And so let's see again, what is the goal function? What is the objective here? Objective is basically to minimize T times 400,000 plus L times 800,000. It just seems like a lot of thousand. Let's just say 4 as in 400,000 and 800,000, so it makes it a little short note. And so now the other thing is that what is the constraint? Let's look at this from the basically the geometric view of these. Let's say here I see, and I just talked about the shortest distance. The shortest distance here would have been a right triangle like that, right? And so let's name this X, right? Then T would be that 6, right? 6 over here also, 6 minus X. And then L would be basically L is going to be square root of, by the Pythagorean theorem, x squared plus 4. 2 to the power 2 is 4. And so I can say the objective function, what I did right now is that I actually found the constraint. T equal to 6x, L equal to square root of x squared plus 4 were the constraint. And now I'm plugging it back in here. So objective is that cost of x is going to be equal to, T is that 4 times 6 minus x plus 8 times square root of x squared plus 4. And then you take the derivative, and that would be negative 4, because 4 times negative 1, and then plus, and you have 8 divided by square root of x squared plus 4 times 2 and 10 times 2x. And this cleans up to negative 4 and plus 8x over square root of x squared plus 4. And then from here, you want to solve for all the critical points of this and C, which is setting C prime equal to 0. Now, if I set the C prime equal to 0, the other part is that it doesn't have any place that the derivative doesn't exist, because x squared plus 4 is always positive and never 0. And so now to set this in, I can set negative 4, take the negative 4 plus 8x over square root of x squared plus 4 equal to 0. That is becoming 8x over square root of x squared plus 4 equal to 4. You simplify it out and you get 2x equal to square root of x squared plus 4. And that is 4x squared equal to x squared plus 4. And then x squared minus, then it will be 3x squared equal to 4, and x is going to be plus minus 2 over square root of 3. So now the next question is, so we have these two critical values, but x equal to negative 2 over square root of 3 is not going to be acceptable. So the only one that is acceptable is this. Now let's see what method we can use. Go back up here. Is there, can I say that what is the domain? What values can x take? X can be 0 right here, or it can be as big. So p can be right here and x be 0, or p can be right here and then x would be 6. So the domain is 0 and 6. Now that we know the domain, let's see, we can use and it's a closed interval and we have a continuous function. We can use the closed interval method, and with the closed interval method, all I need to do is to plug in the one end, the other end, and the critical point in there, and then I get 3 values. And remember, each of these are in $100,000. And within these 3 values, this is the smallest. This is the smallest cost that I can get. The biggest cost would be if x was 6. That would be connecting the refinery and storage tank directly. And then the value is $3,790,000, and approximately takes figure out what the square root of 4/3 is, and then use that to figure out in the previous part, figure out T and S and add them together, and you figure out how much of the length of the pipes you're using, and also you can figure out how much where P is located by using square root of 4/3, and that is P is going to be 6 minus square root of 4/3 away from the refinery.